Hey guys, it's Coach Spartans and Notes. It's the most exciting part of your day. Playing geometry and similarity, student handout number 5. This is about to be a whole lot of fun. Really looking forward to this. I do feel like I'm about to blow your mind, but here we go. Janie and Maguel are painting a mural in the school gym. They will need to paint the entire wall blue, except for the circular school logo. How can Jamie and Maguel determine how many square feet they will cover? So, for example, they have this wall here, and they're going to paint the whole thing except for that circle. So how could they figure out how much paint they need? Well, what if they just measured the whole rectangle wall, and then they measured the circle? And then subtract what the circle is area-wise minus the rectangle. So to find the rectangle, they would go, they would just need the base and the height of the rectangle, okay? So they would just need to get the measurement there and there. And then for the circle, right, they would need pi times r squared. So they would just need the radius. Or they could measure from one side to the other of the circle, get the diameter, and then they would have the radius. And then they could subtract. So they could subtract the rectangle or the circle minus the rectangle. Let's put that in words. They could calculate the area of the rectangle then subtract the area of the circle. So they would need to measure the top of the wall or the bottom of the wall, how high the wall goes, and then they would need to measure how wide the logo is. That would be the 3 things they would need. So today, they are going to take multiple shapes and figures, combine them together, and we kind of got to see where they are and then figure out the area of each and then either combine them or subtract them. All right. First, let's get started with Guess This Fortnite Dance. Here we go. Hang on, we're waiting.
Dancing dump. Oh.
All right. I'm going to give you the answers as we go today. Please make sure they're not cheating. Composite figures. A composite figure is made up of 2 or more shapes, and we can find the area of a composite figure by decomposing the figure into familiar shapes. Then, once we figure out the area of each, we're going to add or subtract. Depending on, do they want to know the total or do they want to know the part missing or what they want. But we have to break it down into figures that we know, so we have to decompose. All right, this is a home plate. But that's not what we want you to see. It is a home plate, but a home plate is actually a triangle. I didn't do that perfect. It is a triangle and a rectangle. Okay? So I'm going to color in the triangle in blue. Maybe you see it. Okay. And then I'm going to color in the rectangle in yellow. Maybe you see it. All right, there's our figures. So we need to figure out the area of the yellow there, and then we need to figure out the triangle area, excuse me. All right, so they've kind of helped us over here. The first shape that I see is a triangle. The second shape that I see is a rectangle. The formula for a triangle equals 1/2 times base times height. The formula for a rectangle is, I need to do the rectangle in yellow, don't I? Is area equals base times height. Now let's go plug in our values. All right, the triangle. How do we figure out the dimensions of the triangle? Because on the triangle, we need the base and we need the height. I don't have either one of those. Well, you do have the base because the triangle goes from here to here, right there where my red is. Same thing as the bottom. See how the bottom is 9? Well, the triangle is also 9, the bottom of it. Well, how do I figure out the height of the triangle? Well, if this whole thing right here is 12, this side over here that I'm highlighting in red is 8. What is the part in green right there? Okay, if the whole thing is 12, this part over here to right there is 8, then what's the missing part? It is 4. Okay, so the height of the triangle is 4, the base is 9. So now we're just going to go plug in our numbers. Area equals 1/2 times 9 times 4. Area equals 18 feet squared. All right, the rectangle is, we'll do this then, is 9 by 8. 9 by 8. Okay, not 9 by 12, because 12 goes all the way to the top of the triangle. I only need to go to where the triangle starts, because remember, I divided them up. They're two different shapes now. So the rectangle is 9 times 8, so it's 72 feet squared. Now, what is the area of the whole thing? What do I need to do? I just need to add those two numbers up. Okay? I just need to add them up. So it's going to be 72 plus 18 equals 90 feet squared. All right. I'm going to play another song while you copy all that.
Second round.
All right, I'm not going to play the answer this time. Same song.
Third round.
All right. Shape 2. Here we go. Where are some shapes? Let's do it in purple. All right. I see. We can go right there. And then we create a what? A triangle and a rectangle. All right. If you don't see them, let me highlight them for you. There's your rectangle. And your triangle is right there. All right. So we have a rectangle and we have a triangle. The formulas for a rectangle is base times height. And for the triangle is half times base times height. So we're just going to plug in all of our values. So area is going to equal all right, here we go. The rectangle is 15 is the base times the height of 6. So it is 15 times 6, which is going to give us an area of 15 times 6 is 90 meters squared. All right. Now, the triangle, the base is obviously 4 meters. We can see that. What is the height? What is that purple line? How tall is that? Well, if we know that the whole bottom thing down there that I just colored over, that right there, is 15, okay? That's 15. That's 5. What's left to be the purple part there, okay? So if the whole thing's 15, this little part to here is 5, what's left for the rest of it? It is 10, okay? So then you're just going to multiply all those on your calculator, and you're going to end up with area equals 20 meters squared. Now, you just come over here and you just add them back together. So your rectangle is 90 plus your circle, which was 20. And you're going to end up with 110 meters squared. I will zoom out so you can get it all there. Next fortnight.
Foot up, left foot slide, left foot up, right foot up, left foot slide, left foot up.
All right. All right, so here we go. Let's discuss different ways that we could determine the areas below. All right. If we needed to solve, I'm using my highlighter here. If we needed to solve this first one, here's what I see. I see a big old rectangle with a part missing. See my big rectangle? And then in red, I see a part missing. Okay, that's what I see. So I would figure out the whole rectangle, and then I would figure out the missing part. That's what I would do. And then I would subtract them. Okay? So I would do that. So draw a line there. All right, the next one, I see a big rectangle. I've shaded in blue there, right? And then in green, I see a trapezoid. So I would figure out the blue rectangle first, and then I would figure out the trapezoid, and then I would subtract them. That's what I would do. All right, on the third one, what do I see here? I see a rectangle again, okay? See a rectangle with a piece of it cut off. And if I draw a line, I'm going to draw a line in black. If I draw a line, actually I'm going to draw it purple. What shape is in purple there that's cut off? That's not there. A triangle. So I would figure out the area of the rectangle and then figure out the area of the triangle and subtract them. That's what I would do. All right, on the next one, what do I see? First of all, I see a square right here. Everybody sees that? The next thing I see is half circles. If you combine those two in yellow, you would make a full circle. But I see two halves there, so that makes a full, And then on right here in red, I also see another two halves, which would make a whole circle. So on that one, what I see is a rectangle and then two circles. That's what I see on that one. So on that one, you would find the area of the rectangle. Then you would find the area of the circles and add them up. All right. Let's play a song.
Next.
All right. So this time they tell us what we have. They tell us that we have a rectangle, and they tell us we have a trapezoid, which we should be able to see those, but they tell us. So they said determine the area of the shaded region. So we need to figure out what the trapezoid is and then subtract the rectangle, and then it'll give us what's left in shade. Okay? So to do that, I'm going to do the rectangle here. It's going to be in blue. Okay? Now, the rectangle is 7 inches right here. It tells us right there. And it's 5 inches right there. It points to it. So it tells us. So the rectangle is, okay, remember the formula is area, equals base times height. So it's going to be area equals 5 times 7. Area equals 35 inches squared. All right. The trapezoid, which is, all this yellow stuff here, to figure out that one, so I'm going to go trap here. The formula to that one is area equals 1/2 base 1 plus base 2. It was that funny formula we learned yesterday. Okay. Then you're just going to plug all your numbers in. There's base 1 or base 2, whichever one you want to call it. There's the other base. There's the height. Okay. So you're just going to plug them in. Area equals 1/2 times or plus 1510 Hey, there's all your numbers plugged in. And when you enter all that into your handy-dandy calculator, you're going to get the area of the trapezoid equals 100 inches squared. Now, you're going to go 100 minus the rectangle, and you're going to get an answer of 65 inches squared, and that is your answer. All right, while you're writing that down, I'm going to play another song.
I got what you like, yeah. Don't put up. I got what you like, yeah. Don't put up.
All right, that was number 6, by the way. Lots of steps, so you won't have many of these problems, okay? But it is a lot of steps. This one's even more steps. All right. Be a lot of highlighting, so follow with me. A patio is being landscaped with trees and shrubs. How many square feet of landscaping will be around the patio? The patio is that marked off spot in the middle, okay? First of all, let's figure out how big the whole shebang is. Well, Coach, you're going outside the box. I understand that, but I'm going to figure out this whole area, okay? The entire thing. That's the first thing I'm going to do. We're going to call that big 1, okay? And then call it big square. All right, or rectangle, whatever. What is the length? It is all of that. So it is 14 plus this little part I'm doing in red there, plus 3. So the whole thing is 17. Oh, let's write the formula. Area equals base times height. All right. The base was 17 times the height. The height is 8 plus this part right here, which is so plus 3. So it's 11. Area equals 17 plus 11 is 187 feet squared. All right, that's the first thing we needed. I'm going to erase all of this stuff I have up here so I can continue to show you. All right, now we need, I'm going to do this one in yellow, we need the patio because we have to subtract it because we're not putting shrubs in the patio, right? All right, so there's the patio. What is the size of the patio? Well, how do we figure that out? What is this? Okay. Well, if we know that this whole part is 14, it's missing this little part right here, which is 3. So it's 14 right there. Minus 3 gives you what is left. Okay. So the patio is going to be 11 feet long there. All right, so I'm gonna go ahead and start writing this patio. The formula for that is area equals base times height. How do I know that? Because it's a rectangle. I can see that that's a rectangle up there. I know the base is 11. What is the height? All right, this part right here in red, what is that? Well, in blue here, if I know the whole thing from there to there is 8, and I know this other part shaded in blue is 3, what's left? 8 minus 3 is 5. Oops. So the answer is 55 feet square. All right, that's how much the patio takes up. We can't just subtract those because if you remember, we did the whole big square. Okay, remember? But this part I'm shading in red here doesn't exist on our thing. Nothing's there. We don't have to put trees there. So I need to take that off. So how do I subtract that? We'll find the area of it. It's obviously a rectangular square. So we're going to call that small square. And we're going to call it small square 1. Okay? The formula for that is area equals base times height. Again, area equals area equals. All right, what is those little sections? What are the dimensions of those? What are the dimensions of those in red? Well, it is 3 feet tall and 3 feet wide. So it is 3 by 3. I'm going to do these in red, by the way. Area equals 9 feet squared. Now, there's actually 2 of them. Don't forget about that one up there. Okay, so it's the same size. So it's going to be times 2, which makes it 18 feet square. All right, now, almost done. We can take the whole thing minus the patio, because we don't need flowers on the patio, minus those little sections that we don't have anything there. Enter that in your calculator. 187 minus 55 minus 18. And finally, you're going to be left with 114 feet squared. It is very important that you circle your answer when you have this much going on. All right. Next song, number 7.
Cause I'm Slim Shady, yes, I'm the real Shady. All you other Slim Shadys are just yes, I'm the real Shady. All you other Slim Shadys.
All right. All right, I just had to stop it. My bad. Okay. Whew. Now, next one. That was the most work that we have to do on one, by the way. All right, a composite figure is created using a rectangle, and this is very important, a semicircle. So when you find the area of the circle, it's only half of that, because it's only half of a circle. So make sure you see that's a half of a circle. So when you find the area of the circle, you take half of it, because you're finding the area of the whole circle. So then you got to take half of that, okay? All right. What objects do we see here? They already tell us, thank the Lord. They tell us that I see a rectangle and a half circle there. All right, beautiful. So we can figure out the area of the rectangle first. They want to know the total area of this figure, by the way, so we're going to add it all up. All right, so we have rectangle. Okay, and the formula for that is base times height. $18, 12. 18 times 12 is 216 inches squared. The other figure that we see, we'll do it in yellow, is a half circle. Half circle. The formula for an area of a circle was area equals pi times r squared. Well, coach, they don't give us the r. Well, they do give you the diameter. No, they don't. They give me this 12. Well, is that not from one side of the circle to the other? Then that also is 12. So that is the diameter. So if the diameter is 12, what is the radius? The radius is half of that, right? So the radius is going to be 6. All right? Pi times 6 squared, you can enter that in your calculator, is going to give you 113 Now, this is the whole circle. I only need half of that. So what do I need to do to go from 113 to get half of it? Because I only have half of a circle, not a whole circle. So I need to do what? Divide that by 2, and then I'm going to get 56.52 inches squared. That's half of the circle. Okay? And then the last thing I need to do is add them up. So it is 216 plus 56.52. And the answer is 2.52 inches squared. All right, next song number 8. Why don't you write that?
Down.
All right, that was number 8. Question number 4, find the area of the shaded region. Well, what shapes do we have here? I see a rectangle. And then I see a triangle. Actually, I see a square, not a rectangle, but anyways. All right, so the first shape I see is it's a square. And the second shape I see is a triangle. All right. The formulas are area equals base times height for a square, and for a triangle is area equals half times base times height. Just going to plug in my numbers. This is, excuse me, this is base, this is height, obviously. All right, 9 times 9 is 81. On the other side, still the base, still the height. So it's going to be the same exact thing, except 1/2 times 9 times 9. So add all those up in your calculator, and you're going to get 40.5. They want to know the shaded region, so I'm going to erase that so we can see the shaded region again. If the triangle takes up 40.5, the whole square takes up 81, what do we need to do to find the part that is left? Okay, we need to subtract what the triangle is minus what the square is. So this is exactly what we're going to do. We're going to go, we're going to go 81 minus 40.5, and you're left with, you're never going to believe it, you're left with 40.5 meters squared. All right, why don't you write that? Another song? I know that one. I can do that dance. All right, last one. I know your brain is fried, but here we go. Beth and Jenna worked the following problem on a math test. They both solved the problem incorrectly. Identify the mistake that they made and then solve for the correct answer. So let me kind of show you what they got going here. This is the triangle. This is the half circle. Because looky here, we have a triangle, and then in yellow, I have a half circle. You see it? All right, perfect. The other girl, she has a triangle here, and then she has half circle. All right, so Beth says to find a triangle, you do half times base times height. I agree with that. Half times base times height. So I agree with that part. On a circle, she says you do pi times 8 squared. Well, the diameter is 16, so what is the radius? The radius is 8. So it is pi times radius squared to find a circle, so I agree with that. Okay, so it's pi times r squared. I agree with that. She solved them and got 96. And then for the full circle, she got 200.96. And then she added those up. Well, there's my problem. She took full circle, and it should have been half a circle. I'm going to write this down in words in a second. Okay? She never took half of that. She should have took half of the 200.96. Why? Because it was a half circle. So Beth is wrong. I will write that in words in just a second. Jenna, she did base times height too. I'm good with that. Over here, she did pi. Well, she did the half. She halved her circle. I like that. Okay? Because why does that work? Because you got to take half of your circle. So she went ahead and put it right there. I know it's pi times r squared, but if you're going to take half of it, you can go ahead and put that half there because you're going to end up multiplying it by half anyways. Anyways, this 16 is the diameter. That's not what she should have took, so she took the diameter. That is where she is wrong. Okay? So let's put that in words for you. Let's go back to my fancy pen here, and let's write these in green. Beth calculated the area of the entire circle instead of half the circle. All right, that's one. The other person, Jenna, found the area of the circle using diameter instead of radius. Lastly, the correct answer is 196.48 units. I don't know what units it is, but units squared. All right. Last song. I'll play two songs. That was number 11. All right, number 12 is coming up, last one.
Next one.
Needed some with some bop in. Let's go. I'm unorthodox than the muff. With some bop in. Let's go. I'm unorthodox than the muff.
All right. That's all. The fat guy in the back road. I'll see you on the flip side.